Okay. In the previous lecture, we studied goodness of fit tests. Okay. In chi-squared chapter, in chapter 4, it's about chi-squared. We now have independence. We talked about this. We talked about the rules, and here we haven't solved any examples here. We'll talk about the rules. Then we give an example about this topic today. Here, the given data is should be in a table. Should be in a table like this. Look here. Let me return to. That's it. We need to have a table data like this. As you see, in this type of questions, we have given a table like this. Here, the data are these. We just work on these. We just work on the numbers. Okay? We have a 2 by 2 matrix. Here, we convert it to a matrix and it becomes 1, 3, 2, 1. We have this 2 by 2 matrix. We work on these values that you have in the matrix for solving the question. We do the same as we did before in goodness of fit tests. We do the same, but here, instead of having only one column, we have a matrix. We have 2 columns, or we may have 3 columns. Okay? Look, these data which are given are the observed frequencies. It's similar to the previous. The frequencies are given in the example are the observed frequencies. And this one is O of what? What's the index of this element? The index of that element is the first row and first column. So it's O11. How about this one? This one. It is O12. This one. O21. This one. O22. You need to give the index for each observed frequency. We need 2 things here. We just need 2 things for calculating the chi-square. Chi-square test could be calculated by only the observed frequencies and the expected frequency. We need to find the expected frequency for each of these. For each of these, we need to find the expected frequency. The rule is the sum of observed frequencies, OIJ, minus expected frequencies, EIJ, dividing by EIJ. This is squared. Here we have double summation, I from 1 to n, let's say to n, j from 1 to k. Let's say that if you have k rows and columns. That's it. Here we just find the sum of these. So we need to have an expected frequency for each observed frequency. For each observed frequency, we must find the expected frequency. From the given data, from the given table, we could find the expected frequencies for all the indices. Okay, for all the indices here we have 4 indices: 1, 1, 1, 2, 2, 1, 2, 2. We must have E for each of these indices here. I mean the expected frequency for each of those indices. Here, generally, if you have a table like this, these are which are given. This is nothing and here, these also which are given are the observed frequencies. So all the given data are the observed frequencies. We must find the expected frequency to apply the rule. To apply the rule, as you see in the above here, we just have expected frequency and observed frequency. Observed frequencies are given. We must find the expected frequencies. After finding the expected frequency, we could calculate it. It's easy to calculate. Okay? Here, in finding the expected frequencies, we need to find these things in I dot. In I dot means the sum of all elements in the ith row. For example, in one dot, let me give you an example. If we have these numbers, let's say 2, 4, let's say 8, 5, 6, 2, 3, 7, 5. Okay. Here in I means the sum of all rows, one by one. Here in one dot, in one dot means the sum of these elements in the first row. What's the sum of those elements? 2 plus 4 plus 8, which is 14. This is in one dot. In one dot, and one dot is this one. How about n two dot? And 2 dot as the sum of elements in the second row. That's the sum of elements in the second row, which is 5 plus 6 plus 2 is 13. Then n 3 dot as the sum of elements in the third row, which the sum of these elements is 15. Now we need to find n dot j, not j dot. It's dot j. We have n dot j. N dot j is the sum of elements of the columns, one by one. N dot 1 means the sum of elements in the first column. That's the sum of these elements, which is 10. Then n dot 2 is the sum of the elements in the second column, which is 17. And then n dot 3 is the sum of elements in the third column. We may have more columns or rows, okay? We may have 10 columns and 10 rows. It's okay. But it's not necessary if, that you have the same row and columns. We may have different rows and columns. It's okay. If you have 2 rows and 5 columns, it's okay, no problem. Here, n dot 3 is 15. That's about n I dot and n dot j. Okay, how about n double dot? That's the sum of all elements in the matrix. It is the sum of all elements in the matrix. Okay, that's the sum of all elements in the matrix. Here, n dot dot is the sum of all elements in the matrix. It's 84. Okay. Sorry, it's not 84. It's less. It's 42. And double dot is 42. This is how to find these 3 things. Based on these 3 things, we could find the expected frequencies. So the expected frequencies depend on only these 3 things. N I dot, N dot j, and also N double dot. It depends on only these. Look, for calculating the expected frequency for E11, let's say, E11 is equal to N1 dot times N dot 1 dividing by, and double dot. We already found these, okay? Let's apply this for the above example that you have. Here, what's 011? We have 011, which is 2, is it? It's 2. This is 011. And this is 012, which is 4. This one is 013. How about this one? It's 032, okay? 032 is 032 is 7. These all are given. All the observed frequencies are given. We need to find the same number of expected frequencies as we have for the observed frequencies. We have 9 observed frequencies. We must have 9 expected frequencies. For each of them, we find the expected frequency for the same index. For example, for 011, we need to have E11. What's E11? It is N1 dot times N dot 1 dividing by N dot dot. Okay? You don't need to memorize the rule. It's easy to calculate, to remember this rule. Okay? You don't need to memorize it. Here, and as you see, we have 1, 1. So both have 1 in the numerator. And in the denominator, we always have N double dot. E11 is that. What's N1 dot? N1 dot is 14. And N dot 1 is 10. 14 times 10 is 140. Dividing by N double dot is 42. Find it. Write down it. And then we have E32. It is N3 dot. The first one is the I index, and the second is the column index. Okay? The first one is the row index, and the second is column index. Let me write down here. E32 is N3 dot times N dot 2. Be careful with that. Don't multiply N2 dot by N dot 3. The first one is the row index, and the second is the column index. So we have N3 dot times N dot 2 dividing by N double dot. We already found this all. Just calculate. And you need to find all of them. Then write down all in a table like this. Look. These are given. We calculate E11. For each observed frequency, you must have the expected frequency. We find these all. Then we calculate these. Observed frequency minus expected frequency dividing by the expected frequency. It's similar to the previous rule that we use in goodness of fit test. The same rule. It's the same rule. Only finding the expected frequencies are different. It's the same. We found these all. Calculate these all, okay? Which is this one minus this one squared dividing by this one. We calculate these all, then we find the sum of them. The sum of them is the result. The sum of them is the result. So we say the sum, let's say I from 1 to k, j from 1 to, let's say, n, for OIJ plus, sorry, minus EIJ squared dividing by EIJ. This double summation is the sum of these elements. It's the sum of these elements. Okay? We found each, then find the sum. That will be the result. That's the chi-square test. That's the chi-square calculated. And we need to find the chi-square from the table. From the table, let me the table. Here we have the tables. We find chi-square from here, and then we compare them. We compare those two results. The results that you get from the test and results you get from the table. We compare them and we say, if chi-square test is the calculated one, is greater than that value of chi-square that you get from the table, if it's greater, we say we reject H naught. We reject H naught. H naught is that statement which is given in the example. In the example, always H naught is given. H1 is different from that one, different from that statement. Okay. If you look at this example, as you see here, a study is conducted to determine whether the two attributes, smoking habit and insomnia disease, are dependent. This is H naught. What's H1? H1 if they are not independent. If they are not dependent, okay, means if they are independent. That's it. It is the null hypothesis and the alternative hypothesis that will be given in the example. Now, here, let's check about these values, R minus 1, C minus 1. R is the number of rows. C is the number of columns. That's the first letter of each. Okay? These are called degrees of freedom. These are degrees of freedom. We use it in finding the chi-square of alpha. R minus 1, C minus 1. Look. That's it. It's chi-square of alpha, R minus 1, C minus 1. We look for that value in the table. This is R minus 1, this is C minus 1. Be careful with that. You need to first write down R minus 1, then C minus 1. Okay? That's it. If you look at the chi-square test table, this is t-test, this is chi-square test. So it's okay. You can write down any of them first. I just wanted to check that. This is multiplication of these two. It is multiplication of R minus C times, so R minus 1 times C minus 1. It's multiplication. You could write down any of them first. In F distribution, we have two components for the degree of freedom. That's I confused with that one. Okay, now let's look at this example. In this example, we have, it says, insomnia is a disease where a person finds it hard to sleep at night. A study conducted to determine whether the two attributes, smoking habit, what's the relation between smoking habit and insomnia disease, if they are dependent or independent, means if they are dependent on each other or not. It says if they are dependent, means this is null hypothesis. It says they are dependent, means the null hypothesis H naught is that these two attributes dependent. What's the alternative hypothesis? It is if these two attributes are not dependent. That's H naught and H1. Okay, that's it. Then this data set was obtained. This data set was obtained here. This table should be must not be here actually. It's here. This is yes. This is no. This is insomnia. Okay. It's like that. The table is like that, not like the previous one. Now, we say among the non-smokers, among 18 non-smokers, 10 of them has insomnia, and 70 of them has no. Okay? ex-smokers, 8 of them has got insomnia and 32 not. For the smokers, 22 of them has got insomnia and 38 of them hasn't got insomnia. So these values which are given are the observed frequencies. What should we find? The expected frequencies. Expected frequencies depend on n I dot, n dot j, and n double dot. And just depend on these three things. We must find these all. Okay? From the given data, it's easy to find them. It's easy to find them all. Look, for n1 dot, n1 dot is the sum of elements in the first row, which is 18. Then n2 dot is the sum of elements in the second row, which is 40. Then n3 dot is the sum of these 60. These are n1 dot, n2 dot, n3 dot. Then for n dot 1, it's the sum elements in the first column, which is 40. And then n dot 2 is the sum of elements in the second column, and the 40. That's it. What else should you find? N double dots. We must have n double dots. So n double dot is the sum of all elements, which is 180. Okay, the sum of all elements, or the sum of all observed frequencies, are the n double dot. We now have these all. Then, how many observed frequencies do we have? We have 011, 012, 021, 022, 031, 032. We must have the same number of expected frequencies. We make a table. Look, these are all the given data. Then we make a table like this. We write down all the expected observed frequencies here in the first column: 011, 012, 021, 022, 031, 032. Okay? We have these observed frequencies. We need to find expected frequency for each index. Okay? for E11, E11 is N1 dot times N dot 1, as both are 1, both indices. It's 1, 1, means the number of rows, the number of columns, both are 1. It's N1 dot times N dot 1, divided by N double dot. You divide all by N double dot, which is 17.78. Then for E12, it is E1 dot times E dot 2 dividing by N double dot at 62.22. We calculate these. It's easy to calculate as you have these all. As you have these all, it's easy to multiply and divide these. Okay? Any of the expected frequencies could be obtained by multiplying two of these, to this and this one from the rows, one from the columns, multiply two of them, dividing by N double dot, based on the indices, okay? After finding all E, we say observed frequency minus expected frequency at the same level for each one, okay? Dividing by squared, we say observed frequency minus expected frequency squared, dividing by expected frequency, divided by expected frequency. We get these values. Look, these all values must be positive. Be careful with that. We must get only positive values. Okay? Now, the sum of these is chi-squared test. Chi-squared test is the sum of these elements, the sum of these numbers. It is the chi-squared test. Now, after finding the chi-squared test, we must find chi-squared from the table. For which components, how many rows and how many columns do you have here? What's R? Little r is the number of rows. R is 3. We have 3 rows. What's the number of columns? 2. We need to find chi-squared for alpha C minus 1 times R minus 1, or R minus 1 times C minus 1. From this, R minus 1 is 2. And then C minus 1 is 1. Multiply these two, write down it here, which is 2. Okay? That's it. Now, what's alpha? Alpha must be given in the example. Must be given in the example. Let's look at the example. It's given that it's 0.05. It's 5%. You need to write down as a decimal point. It is 0.05. Okay. Now, what do we do? We need to look for chi-squared of 0.05 and 2. It's C minus 1 times R minus 1. Okay? And that to obtained from the number of rows minus 1 times number of columns minus 1. 3 minus 1 times 2 minus 1 is 2. And this 0.05 is the value of alpha, which is the significance level. It's always given in the example. Now we look for chi-squared of 0.05 and 2. 0.05 and 2. This is 2. What's 0.05? That's it. It's 5.99. It is 5.99. We write down here. So chi-squared of 3 minus 1 times 2 minus 1 and 0.05 is 5.99. We just, in the table, we just have 2 decimal points, but here we have 3, okay? It's okay, no problem. Now, we compare the chi-square test with the chi-squared from the table. We already said that if the chi-square test is greater than the chi-square from the table, we reject the null hypothesis. That's it. We reject the null hypothesis if we obtain this, if the chi-square test is greater than chi-square from the table. What if not? What if it's not greater? We accept it and we say that statement that we have for the null hypothesis is true. Okay? What if in the given example, in the example that we solve it, we said that these two, smoking and insomnia, are dependent. This H naught. If this is obtained, if we obtain this one, if this is true, if this is true, means we will reject that statement. We say they are not dependent. If it's not true, means if chi-square test is less than chi-square from the table, we say we accept H naught. We accept that statement in which those two things, smoking and insomnia, are dependent. We accept that statement. But if it's not, if we get this one as it's given, we reject H naught. And we say that statement is not true. The difference from that statement is true, which is H1. Now, we already found chi-square tail, which is 12.55, is the sum of these elements. Okay, it's 12.55. And chi-square from the table is this one. We compare these. As you see, chi-square test, this is chi-square test. And this is chi-squared of 4.05 alpha n minus r minus 1 times c minus 1, which is 5.99. Which one is bigger? Chi-square test means we reject that statement which we have for H naught. We reject that statement. Means both smoking and insomnia are not dependent. They are not dependent. Yeah, as we have this one. Chi-square test, which is 12.55, is greater than this one that we get from the table. We say we reject H naught and we conclude there is a significance evidence at 5% significance level to conclude that smoking habit and insomnia disease are not dependent. Okay, that's all. Alpha. Alpha. It's the value of alpha. التيبل كابك عندنا chi-squared alpha c minus 1 times r minus 1. Okay, that's alpha. لو أنا هلب alpha بيا لو أنا بمشي بيا that person of significance level, you should know that's alpha. Okay, I need to write down as a decimal point, then as a decimal number, then calculate from the table. Look, here we have another one. And look at homogeneity. Homogeneity is the same as independence. It's the same as the previous one. It's the same. We do the same as before. Here, It's okay, nothing actually. The procedure to conduct the homogeneity is the same as the test of independence discussed here. So we don't solve examples here. We just look at this example. As you see, even the format of the example is the same as before. So you do the same. The observed frequencies are given. We need to find the expected frequencies. From these two, you could make the table. Okay? And then we get the result and we compare the chi-square test and chi-square from the table. That's it. That's all actually. As you see here, use 1% significance table to test whether the proportions of color preferences are the same for male and female. This is the age limits. Okay, if it's the same for a male and female, it's age limit. What if it's different? It's H1. That's how to write down the null hypothesis and the alternative hypothesis. And this is alpha, which is 0.01. And we also have this table. From the table, we could get chi-square tests. And from the number of rows and columns, and also alpha, we could get the value of chi-square from the table, comparing them. If chi-square test is bigger, we say we reject the null hypothesis. If not, we don't reject the null hypothesis. And that's okay. So for homogeneity, there is no solved examples actually, because it's the same as before. It's the same as the independence. Okay. So it's the end of this chapter. As you see here, we have a list of exercises. Okay. So it's the end of this chapter. Let's take a break. Then we'll be continue to start a new chapter. We now have a new chapter. It's about analysis of variance. Through this chapter, we talk about one-way ANOVA, solving examples or questions by using one-way ANOVA manually and by using Microsoft Excel. I'll tell you how to use Microsoft Excel in solving this type of questions. First, we talk about analysis data using one-way ANOVA. We use one-way ANOVA to analysis of data. And then we use Microsoft Excel for doing that, for doing the same thing. Here, it's nothing, it's only an introduction actually. In this chapter, the example which is given is in this forum. It is in this forum. The data which are given is in this forum. We have some columns. Each column called a level, okay? Each column represents the data for a specific group. Let's say here for the first column, we have these data. These all data are for the first group. These are for the second group up to group K. Here, we need to find these. In some examples, sometimes these are given. Sometimes these are given. Y1 dot means the sum of these elements. Y1 dot is the sum of these elements. Then Y2 dot is the sum of these elements. We write down each at the end. We write down the total at the end or in the last row. Here, the sum of these elements is called YK dot. And Y double dot is the sum of all. Is the sum of all elements that we have for all groups. Or you could just find the sum of these, which is y double dot. Each of these is the sum of a column. Okay? If you just find these, you'll get y double dots. That's it. Y I dot, it's what I talked about. It's all what I talked about. Here, in this type of questions, we just need to find two from these three things. We have SST, SSTRT, and SS. If we just find two of them, it's enough. It's enough to find just two of them that could be calculated from the table, from the given table. And then the third one depends on the other two one. For example, if we find SSTRT and SSE, the sum of these two is SSE. Okay? The sum of these two is SSC. So you could get SST also if you just find two of them. So what if we find SSTRT and SST? What if we find these two? How to get this one? This one is, we just move this to the other side. We get SST minus SSTRT. I'm gonna tell you what are these. What are SST? What is SSTRT and SSE? Here. So if we just find two of them, we could calculate the third one based on the other two. Okay, using this equation. We say SST is equal to SSTRT plus SSE. You should know this rule, okay, this formula. Here, SST is the total sum of squares. It is the total sum of squares. We'll talk about its rule later on, okay? SSTRT is the sum of squares due to the levels, or each level. And SSE is the sum of squares due to the errors. The sum of these two due to levels and due to errors, the sum of these two is SST. We said before that SST is SSTRT plus SSE. So the sum of these two is that one. That's the above rule. That one is. Where is it? That's it. That's the rule. Now, SST could be obtained by this. Could be obtained by this rule. You should know these rules. These rules are not given during exams. You should know them. We say SST, which is sum of totals, sum of square totals, okay? Sum of total squares is Yij squared minus, this is the double summation of Yij squared minus Y double dot squared minus over n. What we do here, if we have a table, let's say we have group 1, group 2, let's say we have 3 groups. If here you have, let's say 2, 1, 5, you have 6, 4, 2, 1, 7, 5. Let's say if you have 4 here also. It's okay if we don't have the same number of data for each group. Even if you have different data, different number of data for the groups, it's possible, it's okay. Now, how to calculate SST for this data groups, okay? We say we need to find here Y1 dot. Y1 dot is the sum of elements in the first group, in the first column, which is 12. I'm just gonna write down 12 here. This is y1 dot. How about y2 dot? It's the sum of elements in the second level, which is the second column. It is 12. It's still 12. For the third one, it's 13. How about y double dot? It's the sum of all elements for all groups. Okay? It's the sum of elements for all levels, which 12 plus 12 is 24, plus 13 is 37. This is 37. What's capital N? What's capital N? Capital N is the number of all elements at all levels. How many elements do you have in all groups? In the first one, we have 4. In the second, we have 3. In the third, we have 3, which is 10. This is 10. Capital N is 10. Now, we say SST is the sum of squares. Sorry. We just find the square of all elements, square of each element, and then we find the sum of them. And then minus y double dot squared divided by n. So what's y11? It's y11, y12, that's it. Okay, up to the last one. We find the square of all elements, which is 2 squared plus 1 squared plus 5 squared plus 4 squared plus 6 squared plus 4 squared plus 2 squared plus 1 squared plus 7 squared plus 5 squared. These are this double summation. You calculate it, okay? Then minus y double dot squared. What's y double dot? It's 37. 37 squared divided by n. N is 10 minus 37 squared divided by 10. This is SSE. It's how to calculate SSE. Okay? Then, as I said before, we need to find 2 of the 3 sum of squares. We need to find 2 of these 3 things to get the third one. Then, how about SST? We have a rule for SST. And SST is, sorry, SSTRT. That was SST. And now we have SSTRT. SSTRT is yi squared over ni. What's ni? We have n1, n2, n3 here for this example. As you have 3 levels, we have 3 columns. Means you have n1 as the number of elements in the first column, which is, based on this example, n1 is 4, n2 is 3, and 3 is 3. We have 3 elements in the second and third columns, but we have 4 elements in the first column. So that's n1, n2, and n3. Then we say yi dot squared. What are yi dot? It's these totals. These are. We say it's 12 squared over n1 plus 12 squared over n2 plus 13 squared over n3. That's the summation. This one is y1 dot squared over n1 plus y2 2 dot square over n2 plus y3 dot square over n3. We have them all. We already found the total elements at each level, which are y1 dot, y2 dot, and y3 dot. And we also have the number of elements at each level, which are n1, n2, n3. So it's easy to calculate this. Then minus y double dot squared over capital N. Capital N is the total number of elements, which is 10. And we already found y double dot, which is 37, minus 37 squared over N. Calculate this, which is SSTRT. We now have, the rule is like this, SST is SSTRT plus SSE. We found this one and this one, okay? This is SSTRT, and in the previous one, we found SST. So you could get SSE by moving this to the other side. So SSE is SST minus SSTRT. Okay? We found these two. Subtract SSTRT from the total one. SST is the total. We get SSE. After finding these three things, try to make this table. Make this table. Okay? Make this table. Here, just write down factor here. Write down error here. And write down total here. Write down the value of SSTRT here, SSE here, and SST here. Then, what's K? K is the number of levels, the number of groups, or the number of columns. Okay? The number of columns is K. In that example that you worked on is 3. Okay? We have 3 minus 1, which is 2. Write down 2 here. And n minus k is 10 minus 2, 10 minus 3, which is 7. N is, capital N is the total number of elements. And k is the number of columns, 3, which is 7. And n minus 1 is 9. N minus 1 is 9, or the sum of these two must be the same. Then M is TRT. I'm gonna tell you what's mean by these two. This one could be obtained by this one dividing by this. SSTRT dividing by this number that you have here, which is 2, we get MSTRT. And MSE could be obtained by SSE dividing by this, dividing by 7. We get MSE. And then F calculated or F test is the division of these two. Dividing MSTRT by MSE, we get F calculated, and that's it. Then we need to find F from the table. Then we compare them. We need to find F from the table and we compare. This is F calculated or F tests. F test and F from the table. We compare them and we decide if we accept or reject the null hypothesis. So it's important to know this table. It's important to draw the table first. After finding these three, draw the table, put them in here. These are given. K is the number of columns, N is the total number of elements. It's easy, okay? You could get it from the table. Then, after filling these also, you could get these by dividing this column by this column, okay? we divide SSTRT by K minus 1 to get MSTRT, and dividing SSE by N minus K, we get MS. We just find these two. We don't need to divide these two. We don't need to divide these two, okay? We just work on these two. This one, divide by the below one, the above one, dividing by the below one, we get the calculate. We have no rules here for F test or F calculated as before, as we had before. لا تركاني بيشو رولك ما هبو أما هم بم رولا أما كايسكو تيستا ياخد F تيستا أشتكى calculate يكي. But I'm near a cat division to one. It's the division of these two. How to get these two? By dividing this one by that one, and this one by that one. We get those. And how to get these two? From these rules. Okay? So it's important to know these two rules. SST is equal to this formula. And SSTRT is this one. Finding these two, you could get SSE. SSE is SST minus SSTRT. You get it. So now we get these values. We have these three values. Then these degrees of freedom could be obtained from the given data. It depends on the number of data and number of columns. K is the number of columns, and N is the number of data that we have in the table. Then we need to find mean square. Mean square for SSTRT, dividing by this one, we get MSTRT, and MSE is SSE dividing by N minus K. Now, look, MSTRT is the mean square values for levels. It's mean square value for levels. And MSE is mean square value for error. Okay, this is for error and this is for levels. As these two depend on SSTRT and SSE. So SSTRT is the sum of squares due to levels. Sum of squares due to level is SSTRT, which is this one. Sum of squares due to levels. And this one is the sum of squares due to error. MSE is the mean square value for errors, and this is mean square value for levels. That's an F naught is this one. This F naught and also F calculated, you could say. We say if F test or F calculated is greater than F from the table, from this table, from these tables. Here we have different tables for F. It depends on alpha. If alpha to be 0.25, we use this table. If alpha to be 0.10 or 0.1, we use this table. We have different tables for F test. If alpha to be 0.05, we use this table. And for each alpha, we have a table, okay? We have different tables for that. Now, we say if F calculated is this value that we get here. It's F calc or F naught. If that value is greater than F from the table, F of alpha k minus 1, n minus k. K minus 1, n. You cannot change these two places. Never do this. You must write down alpha, then k minus 1 first, and then n minus k. Okay? If you interchange their places, you'll get a wrong answer. Okay? Yes. Now, we say if f calculated is greater than f from the table, we reject the null hypothesis. We reject the null hypothesis. If not, we accept the null hypothesis. Look at this example. In this example, we have some more details here. We have this, that's it. We have given that. Here it says 3 different types of alcohol can be used in a particular chemical process. We have 3 types of alcohols. The resulting yield in percentage from several batches using the different types of alcohol are given below. For type 1, type 2, type 3, we have these 3 types of group 1, group 2, group 3. Okay? It says test whether or not the 3 population appear to have equal mean using alpha to be 0.01. This is equal means 3 types or 3 kinds of alcohol has the same mean. Okay, equal mean means has the same mean. This is null hypothesis. It's always given in the exam. Null hypothesis must be given in the exam. What's the alternative hypothesis or H1? H1 is that if at least 2 of these are not equal, at least 2 of them are not equal, or at least 2 of the types of alcohol have not the same mean, have no equal means. That's H1. H0 is given. H1 is something different from the H0, from the null hypothesis. So now it's important to write down the hypothesis. You must always write down hypothesis during exams. In solving questions, you must write down the hypothesis, null hypothesis and alternative hypothesis. Here, the null hypothesis is all have the same mean. It's denoted by mu, okay? If mu1 equals mu2 equals mu3, means they have equal means. What's the alternative one? It is if at least 2 of them are not equal. Mu I doesn't equal to mu j. Or you can say mu1 doesn't equal to mu2. Or mu1 doesn't equal to mu3. Or mu1, mu2 doesn't equal to mu3. You can see that. At least one of them are not equal. Okay? It's the same as that. It's the same. Okay? Now, first, you need to find y1 dot, y2 dot, and y3 dot. It's important to find first because we just focus on those 3 things in calculating SST and SSTRT. Here, y1 dot is the sum of these elements. It is the sum of these elements. It's 75. I saw that. It's 7. Okay, 75. Okay. Y1 dot is 93 plus 75 plus 94. Write down it. Then Y2 dot is the sum of these 3 elements. And Y3 dot is the sum of these 3 elements. How about Y double dot? Is the sum of these 3. Or it's the sum of all elements here. Total elements. Okay? The sum of all is. ليه وانا اجي نبدا نمسك ليه لما بس شو قا اجى سكولو ماكين بس اجى سروناك بس اجى سكولو ماكين بوي يشيني اكسل اجى سكولو here it's here we have y1 dot y2 dot y3 dot but in the previous one it depends on both rows and columns. That's why it's important that indices. Where's the indices? Okay. Where's ing? Now, and also y double dot. We have these. In solving the question, we need little n's, n1, n2, n3, and we need capital N. We also need k. K is the number of columns. K is 3. What's the number of columns? Okay. And n1, little n1, is the number of elements in the first column. Little n2 is the number of elements in the second column, and so on. Here, n1 is 3, which we have 3 elements in the first column. n2 is 3, and n3 is 3. لو أنا بلنبوها السكان سأقول n12. No, because here we will have different data, different number of data for each group, as you see here in these examples. Okay, we have different number of data at each level. That's why you must always find n1, n2, n3, and so on. How many columns do you have? Or how many levels? Depends on the levels. Here we have 4 levels. We must find n1, n2, n3, and 4. And here we have n1, n2, n3. Okay, so it's important to write down all in little n's. n1, n2, n3, we have 3. And capital N is the total number of elements. We have 9 elements. We have 9 numbers. Okay, that's all what are given. And these are calculated. We don't need anything else except these things. K, little n, little n's, capital N, and also sum of elements at each level and total sum, which is y double dots. We just depend on these things to find the values of SST and SSTRT. Now, we calculate SST. SST is each element squared and find the sum of them. How many elements do you have in the total levels? In all levels, 9. We say it's 93 squared plus 75 squared plus 94 squared plus 95 squared plus this one squared plus this one squared plus these all squared. What's the double sum of y double dot squared? We get this one. Okay, this one is the square of all elements and find the sum of them. Okay, here you have dots means for others. The same. Now, minus y double dot squared over n. What's y double dot? At 778 squared. Dividing by n, we have 9 elements. dividing by 9. Calculate this. You get 620.2222. Like this. You get this one. قبيزنا calculation yapayım şunu da. حاسبة بيبت يمكن أسف. At 620.222. Okay, this is SST, and you can also find SSTRT. SSTRT is yi squared, yi dot squared actually. Yi dot squared dividing by ni. We have them both. Yi dot is the sum at each level, and minus y double dot squared over n. Look, in both rules, we have y double dot squared over n. We have this. We subtract this from the summation. In the first one, you have double sum of yij. It's the sum of all elements squared. But here, for SSTRT, it's due to levels. Due to levels means we find the sum of each level squared dividing by the number of elements in that level, which is yi dot squared over ni. It's y1 squared, y1 dot squared over n1 plus y2 dot squared over n2 plus y3 dot squared over n3. We already found these. These are y1 dot, y2 dot, y3 dot. We have these. At this 262 squared dividing by the number of elements at this level, which is 3. Then y2 dot, which is 279 squared dividing by the number of elements at this level, which still we have 3. And also 237 squared dividing by 3. But if the data are like this, here it's the sum of these squared dividing by 3. But here we divide by 5. Here we divide by 4. Be careful with that. We divide by ni, by n2, n3. They may be different. And so we just calculated it. It is the summation minus 778 squared over 9. 778 squared over 9, which is 297.555. We have these two values. We now have SST is 620.222 and SSTRT is 297.555. How about SSE? SSE is the total sum minus total sum at levels. This is total sum at levels and the total sum. Bigger one minus smaller one, which is 620.222 minus 297.55. You get a value which is 322.6667. We now have these three things: SST, SSTRT, and SSE. You need to write down them in this order. First, you must write down SSTRT. This is SSTRT. You must write down this in the first. Then SSE. And then SST. Okay, you must write down them in that order. Now we have K and N. In this box, we write down K minus 1. K is the number of columns. We have three. We have three groups. Okay? And in the second, we have capital N minus K. Capital N is the total number of elements, which is 9, minus K is 3, and you get 6. In the last one, we have N minus 1. We have N minus 1, or the sum of these two. The sum of these is 2 plus 6 is 8. It's the same as to say 9 minus 1 is 8. Then we need to find mean squares due to level and due to error. Due to level in the above and due to error in the below. Then we say in this box, the value could be obtained by dividing this one by this one. Okay, which is 297.555 dividing by 2. We have 2 in the second box. Okay, yeah. This value can be obtained by dividing this one by 2. And also, this value can be obtained by dividing this one by that value, which is 6. Then we get these two values. Dividing these two, we get F calculated. Dividing the above one by below one, we get F calculated. That's it. Okay? Be careful with the orders of these especially. First, you need to write down SSTRT, then SSE, and then SST. Okay? This is SST, this is SSE, and this is SSTRT. And also here we have K minus 1. Here we have N minus K. And here we have the sum of the above ones, or K minus 1. ليرة عسانة يكسر مدابة شواقي جمالك تسك مدابة شيو جمالي تسك يوزناك مدابة شيو إيش ما بيني. Okay, now we divide these two. أمسرو دابة شو إخبار واقع كم تسكيت F calculate or F note or F test. We get that. Now we need to find F from the tables. We need to find F from the table. How? We say it is. Sorry, it's written here. That's it. We need to find F of alpha K minus 1 N minus K. Alpha K minus 1 N minus K. We say if F calculated is greater than F from the table, we reject the null hypothesis. We reject the null hypothesis. Our null hypothesis in this example is that all the types of Cahul, as we have 3 types of Cahul, have equal means. We reject this one if F calculated is greater than F from the table. We have given that alpha is 0.01. This is alpha. We need to find F of alpha K minus 1 N minus K. We need to find this one. We already have K and N. And alpha also given, which is F of alpha is 0.01. And K minus 1 is 2, which K is 3 is the number of columns, minus 1 is 2. Then N minus K, N is 9, minus 3, which is the number of columns, is 6. We need to look for this value in the table. First, look at alpha. Look at alpha. And then go on to the tables. Alpha here is 0.025. So that's it. Okay? That's not the table that we need. This one is. Okay? We have many tables for F. This is not, as we have 0.01 for alpha. This is not 0.01, it's 0.1. Okay? What's that? This one is. As you see, alpha is 0.01. So our alpha is 0.01. Our alpha is 0.01. Now we found the table. Then in the table, we look for 2 and 6. First 2 and then 6. Look at the table. In the table, it's given. This is V1. The second is V2. Okay? What's V1? V1 is the horizontal one. It's the horizontal one. V2 is the vertical one. So we look for 2 horizontally and we look for 6 vertically, as we have that. 2 horizontally and 6 vertically. This is V1, V2. Now, let's look at that. Here, this is the second. And then at 6, we have 10.92. That's 10.92. So this is F of 0.01. 2 and 6 is 10.92. What if someone write down in different order? F, here we have F of alpha k minus 1 n minus k. If someone write down to us F of alpha n minus k and k minus 1, it's not true. You get a wrong answer. This is F of 0.0162 for this one, for the strong one. Let's see if we get 10.92 or not. 0.01. This is the table. 6 horizontally. This is 6. And 2 vertically. Sorry. Yeah, 2 vertically. We look for 2 here. It's 99.30. Look, what's a difference we have. Okay, the true value is 10.92. But in changing the order of k minus 1 and n minus k, you get 99.33. They are different. So be careful with the order. It must be k minus 1 and n minus k. So we get 10.92. Means the F value from the table is 10.92. No, it's not true. It's 10.92. That's not true there. So 92. This is F from the table. And already found F calculated. We compare them. If F calculated is greater than F of alpha k minus 1 n minus k. If this is greater, we reject edge notes. If not, we accept edge notes. Look, we have F from the an F calculated or F test, which is 2.7. Okay, 2.76. But F from the table is 10.92. Is this inequality true or not? It's not true because this one is bigger. So this one is bigger. Means we cannot you cannot reject the null hypothesis. So there is no difference in the mean of the three types of alcohols. So we are unable to reject the null hypothesis. Null hypothesis كمان تشبه وثمان هرسي كان همان مين يعني مين كان يعني equal. أجل نتواني أم statement reject كين كواتا أم statement راسته ما نايوان هرسي جورة كالكول كول شيلان همان شماري مين يعني. Okay. There is no difference in the three types of alcohol significance. That's it. That's how to solve questions. Okay? You should know the rules here. The rules will not be given during exams. You should know them. And recognizing the questions, it's easy. It's so easy. Okay? Now, we use Microsoft Excel for solving this type of questions that you will need for your project. In your project, in the data analysis, you need it. You need to find it. Look, these are all exercises. And look, for the same example, for this example, let's find it. Now we use Microsoft Excel for solving the same example, and it's the same for all the other examples. It's only entering data, that's everything. Okay? Look, let's first write down the data. Before we do that, let me tell you something. Here in the above toolbar here, we have data. Click on data. You must have data analysis here. You must have data analysis at the end. Okay? At the end of the above sheet. If you don't have, go on to file, then sorry. Choose option. I can't see this. Let me move this one. Sorry. Here you have more. Choose option. Choose option. Then, when you click on option, you'll get this box. In this box here, in the left, we have these things. Choose add-in, add-ins, choose it. And when you click it, you get this box. At the end, we have this tick. Okay? Choose Excel add-ins, choose it. Click on it. Then click on go. We have next to it, you have go. Click on it. Once you click, you get this box. Here, you need to tick analysis toolbox. Look, the first one is analysis toolbox. Click on it, tick it, and then okay. Let me remove it here. Look, once I remove the tick on that, we have no data analysis here. We remove it. If you have no that, it's the same process as I did here. We go on option, then go on to add-ins, then choose Excel add-ins, then click on go, and then tick the first one, which is written as analysis toolbox, toolpath, sorry. Analysis toolpath. Click on it. Then, okay. Once you click, you'll get the data analysis. You must have data analysis there. We just work, we just do all the operations from that data analysis. Now, we enter the data to the Excel sheet. Here we have, let's say, group 1, group 2, group 3. Or if we have, let's say, kind 1, types 1, type 1, type 2, type 3. We have 3 types. It's naming them, okay? It's easy. Now, we have 93, 75, and 94 for the first one. For the second one, we have 95, 97, and 87. For the third one, we have 77, 76, 76, 77, and 84. We now have all the data. Even if we don't write down these, it's okay, no problem. We don't use the titles in solving the question. But you should know it's written as columns, okay? It's in columns. The levels are in columns. Now, we click on data analysis. Click on it. Once you click, let me show you. As you see, here we have 2-factor. We don't need it. We need single factor, ANOVA single factor. Okay? As we have a one-way ANOVA. Okay? Where in this chapter, we just focused on the one-way ANOVA. So we use ANOVA single factor. Click on OK. Once you click, you get this box. You get this box. Let me show you. Okay. Small, actually. Yeah, make it bigger. Okay. Oh, we lost the data, I think. No, that's it. We now have the data. As I said, we just click on data analysis. Then the first one, which is ANOVA single factor. Okay. Now, in this box, we need to write down the range of our data. Our data starts from A2, look, A2 up to C4, up to C4. But here, what we do, this box, this one must be empty. We click on it, and then we go on to the data from the begin to the end. Select all. You get the range of our data. Now, our data are given in columns or rows. Our data are in columns, as you see here. Column 1, column 2, column 3. Okay? So, we have in columns. Then, you need to give alpha to it. What's alpha? Alpha is 0.01. It was given in the exam. Okay? Then, where do you put the out? Here, click on output range. Where do you want to put the output? Let's show you about that now. Let's show you about that. Problem later this paper. Okay? Click on it. Now that's it. Look, once you click on it, look, this box is empty. Once you click on any box, the location of that box is given. It's sealed. Now click on OK. Once you click, you get the results. Okay? Now, look, this is F calculated, which is 10.0 10.92. It's 10.92. So it is from the table, F from the table. This is F from the table. And this is F calculated that we found from the data, which I give. And this is p-value. Excel depends on p-value. It says if p-value is less than, alpha, it compares alpha and p-value. It says if p-value is less than alpha, we reject S-naught. If not, we accept S-naught. Here, p-value is 0.14081. What was alpha? Alpha is 0.01. Which of these is bigger? P-value is bigger. If p-value is bigger, we cannot reject S-naught. But if p-value is less, we reject S-naught. But here for this example, p-value is bigger than alpha. Means we cannot reject S-naught. We accept it and we say that different types of alcohol have the same mean, have equal means. Okay. Look at this table. Here, the first column, in the first column, we have 3 elements. In the second column, we have 3 elements. In the third one, we have 3 elements, as you have the same number of elements for all type of alcohols. It may be different in another example. Here, this is the sum of all elements in the first column. This is the sum of all elements in the second column, and this the sum of all elements in the third column. These are average for each column, or X bar. These are X bar for each column. It is 262 dividing by 3, this one dividing by 3, and this one dividing by 3. You get this one. And these are variance for each level. For column 1, column 2, column 3. We actually don't work on these here, but in your project, you could talk about this also. You could talk about this and analyze this table and also this table. In this table, we have SST, which is the first one. Sorry, SSTRT is the first one. This is SSE and this is SST. And this is K minus 1. This is N minus K. This is K N minus 1. And these are obtained by this one dividing by this one is that. This one dividing by this one is that. Then F calculated, this is F calculated, is this one dividing by this one. Okay? Then p-value, it's calculated in Excel to decide whether we accept or reject H-naughts. We say if p-value is greater than alpha, it compares with alpha. If it's greater than alpha, we cannot reject the null hypothesis. But if p-value is less than alpha, we reject it. And this is F, which is obtained from the table. We work on these two manually. We work on these two. Okay? We said if this one is greater than this one, we are unable to reject. But if this one is greater than this one, we reject. Okay? That's it. And it's the same for all the other, for all examples. Let's take, let's say, 30, 45, 11. Let's see, we have this. Look, we have different numbers for each level. Okay? Now, we do the same. Let's delete this one first. Okay. We click on data analysis. Then it's the first one, ANOVA single factor. Here we have the range of our data. Click from first to end. Okay, it's in columns. Let's say alpha to be 0.05. Okay, then give us our result from here. Let's say from here. Let's give us our result here. Okay, now click on OK. It gives us here. That's it. That's easy. Okay, what if our data is here? It could be here. Let's say we put our data here. Even it's possible, click data analysis. Okay, then clean this first. Clean this one, and then select the data. Then put the alpha value, and then choose a cell for giving you the result. Let's give us here. Okay, that's it. It's easy. Okay, what if we have the values in column, in rows? Let's say we have okay, we have these 5 data for the first one. Okay, let's say it's group 1. Group 1. And group 2, we have 3. For group 3, we have, sorry. We have 5 for that one. So we have 5 for the first and third groups, and we have 3 data for the second one. Now, if we want to analyze this one, we click on data analysis. Okay, then choose the range of our data. Yeah, this is the range of our data. Then here we have rows. Click on rows. Our data are given in rows, not in columns. Choose the given alpha, and then choose a specific cell for giving you the result. Click on OK. Oh, sorry. That's it. This is the result. Okay, that is the result. It's easy, is it? بدس يشو هلوا أي كشتن بو شوي يلا هفتي ده باشا كشن